Hey guys, it's Mr. Zimmerman, and today we're going to continue to look at some of the topics in Module 3, Topic 2, and we're going to go ahead and take a closer look at if you're able to convert between exponential form and logarithmic form. So let's go ahead and dive in and practice this skill. So this is basically examining the inverse, and being able to switch between the two forms is very useful because sometimes something's more useful in exponential form, and other times it's easier as a logarithm. Let's go ahead and first convert them. So I just want you to remember the general form. The parent function of a exponential is b to an input, and it will give you a number, which is the output. Okay, now I want you to know that I can convert between forms, so I can go both ways. This is how I always read it off to my head. The log has a base, has a subscript, which is the same b, and it's to the output, the other number, and it will give you the x as in the exponent. Logarithms are built to solve for the exponent. It is the inverse of the exponential for the reason. So when I need to do this, I can go ahead and write the log of the base. The base is 3 because 3 is the base. The exponent is x. What is the number that I have it for the output? 27. And that's going to be equal to x. Let's go ahead and look at the next one. Okay, it's flipped. Which one is the b raised to the x? Well, I know it's a decay because b is less than 1. So what is the base? The log of a fraction, that's okay, is equal to 27, and it's going to be equal to x. Okay, let's look at the next one. The log, what is the base? The base is 2 of my output, which is x, is equal to 7. And then for this final guy, the log of my base, what is my base? 27 over 3. Well, that's simply just 9 if I write it as a quotient. And it's going to go ahead and be in parentheses to 5 over 9 equal to x. So voila, we converted between forms. In this instance, we were given all forms in exponential equations, and we converted them into logarithm form. Now let's go ahead and take a quicker look at which form is more useful and why. For A, if you recall, for Math 3 or Math 1, you solve this equation by saying 3 to the x is going to be equal to how many 3's in 27, which is 3. And then you would be like, oh, well, my exponents have to be the same. So x is equal to 3. So yeah, you can use this form to solve it because it's a natural number. Now, what I do want to raise is this can be put into a calculator. And what this is going to ask is how many times does 27 be divided by 3? And that's going to be 3 times, which is what this x value will be. Now, let's look at b. 27 is equal to a fraction to an x. So immediately, I'm like, I don't know how to solve that. So I change it, and in this instance, the log of 1/3 of 27, this can be inputted into a calculator, and it will tell you how many times 27 can be divided by 1/3. This next one, now notice how 2 to the 7th, how everything's on the same side. They're all on the left side. I can easily calculate what that is. So the top form is going to be a lot more useful. This bottom part where the log of 2 to the x, I cannot use this with my calculator. This is not going to help me. Now I look at this next one, and again, I just want you to notice how on the left side, how b and y are both there. So that means I can just evaluate that left side and get a value. I hope this brought a little more introspection on why we convert between forms. Essentially, this is a stopgap in order to solve equations that have x as an exponent. Otherwise, when it's a, when we're dealing with 3 to the x equals 27, and all of our numbers are nice natural numbers, we can solve it. But the moment for B and like D, when we start including some fractions, we want a way so that we can use our tools to solve our problems for us. So I can solve these logarithmic equations even though I don't necessarily know how to do the scratch work myself. All right, guys. See you next time.